Just before we start, let me just see. I can't see your. Oh, yeah, there we go. I can see your screen now. Okay, so let me just give me a minute. I'll just introduce you and then we can start.
Yeah.
All right, everyone, welcome to this inaugural seminar for the Center for Data Learning and Decision Sciences at Ashoka. We are delighted and privileged to have Professor Viral Acharya give this inaugural talk. Viral is a CV star professor of economics, and the star is not somebody's last name, it's just that indicating that he's a star professor in New York University. You can see his website. He's done pioneering work in systemic risk, in asset pricing under liquidity issues, and many other areas. He's received many awards. He's on editorial boards of reputed prestigious journals. But let me just say a few things about him, which kind of also make him stand out. He was a President Gold Medalist from IIT Bombay in computer science. And then he went to do his PhD in computer science, and 1 year later, he shifted to economics. And then, he has variety of, he has just different flavors to himself. So in the year 2006, he released an album, Yado Ke Silsile. It's on Hindi music. Um, I can tell you from my association with him that, you won't find a more kind of pleasant, helpful, and dedicated person. We used to have meetings 7 in the morning because Viral just had a busy schedule trying to do many things in his day at Reserve Bank of India. Okay, so we are extremely pleased, Viral, that you've accepted our invitation, and we look forward to your talk.
Great. Thank you so much. Sorry for the change of time. I'm glad at least you could make it, and hopefully you can give the lecture in 1 hour to those who sign up late. So so Sandeep and I decided on this topic partly because I'm also quite interested in issues relating to heat stress in India, especially on just data and measurement issues. But maybe I'll also be able to talk a little bit about the kind of questions that are becoming important relating to heat stress along the way. And this is joint work with Tim Johnson, Suresh Sundaresan, and Tom Tominen. Unfortunately, my co-author, Tim Johnson, passed away on 31st December, 62-year-old, very young, all of a sudden. So we are hoping at some point we'll be able to publish this paper as a small homage to him. One reason why I like working on heat risk within the set of climate change. So, there are lots of hazards people are looking at in the climate change space. They look at hurricanes, and uh, hurricanes are probably the most studied. Sea level rise is also studied, I would say, somewhat well. Hurricanes have this property that they are very easily predictable geography-wise, and they have very acute damage that they impose, especially on property, and of course, sometimes on life as well. But if you think about the planet as a whole, actually, the incidence of hurricanes is actually in a very small part of the world. It's not that geography-wise hurricanes are affecting a very big part of the world. Now, climate scientists will be quick to correct when I make such a statement that it's all interconnected. These different climatic patterns are not entirely unrelated. But to the extent that the data and the work divides things into hazards, my sense is that heat waves are seen more as a global phenomenon. And for most of us, I think probably the first term of introduction to climate change was, I think, global warming, that the planet as a whole is actually intensifying in its temperature rise because of greenhouse gas emissions and so on. For the US, for example, if you compare the damages that are estimated per year, this is based on some papers that came out during 2013 and 17. What you find is that actually estimated damages in response to heat even though some of them are indirect, are actually quite large. So while hurricanes and sea level rise through flooding cause sort of direct property damage, heat damages are in contrast somewhat indirect. There are property damages due to heat, like in the United States, for example, roofs can collapse, therefore warehouses can actually and factories can have significant damage. But the main expenditures are actually energy expenditure related, air conditioning expenditure related. So imagine if Amazon has a warehouse in Arizona, which has been having 115 Fahrenheit plus, so 40 to 45 degree plus temperatures 10, 15 days in a row, then those warehouses are not as attractive to use because the air conditioning expenditures become very, very large at that time. But there is also labor productivity. There are high contact or high exposure industries like construction, mining, agriculture, in which India still employs 45% of its labor. And even if in US that labor share is down now to below 20%, it would impact the productivity of labor in those regions. Now, the kind of questions, therefore, that are arising is one, if energy expenditures, labor productivity, etc., could have direct impact on the cost structure of companies, does it affect their cost of capital? So do markets price in that companies are in locations that are more exposed to heat risk or heat waves, etc.? Second, what do companies do in order to adapt to heat risk? If they are single establishment or small firms, their capacity to adapt may be much more limited. In fact, a big part of climate finance literature is finding that the small firms are the most vulnerable, actually, that they simply, once there are significant heat waves or significant hurricanes or flooding issues, they simply seem to not survive. There's a greater impact on small firms. And so it alters actually the industrial concentration in the regions where these climate change disasters hit. But just talking about the US again, like this thing is now quite real. California, which is probably the most impacted by heat risk because it leads to wildfires given its tree structures and bushes, brush fires, etc. So they are actually now trying to get people to think more saliently about heat waves. So unlike in Europe, where there are no hurricanes, but they do name their heat waves and floods with names, in US, hurricanes are named, but heat waves are not named. And California is planning to actually start naming heat waves to get people to think more saliently. In fact, what's interesting is that if you think about human fatalities and injuries, while property damages are the highest with hurricanes, human fatalities and injuries are actually the highest with heat stress in the US data, at least. And I imagine that might be the case for India as well. Second, there are some sort of completely in the tail kind of risks, like the amount of water that you would need to keep nuclear power plants at reasonable cooling levels. Both heat and water stress could become very, very high in that sort of a risk sense. And then again, coming to California and a little bit further north in Oregon, in California, actually, one municipal town got completely ravaged by a wildfire and they had a bond default. One utility company in California, so utilities in the US, like in India, don't always pass on the user cost to the consumer. So they're always a little bit vulnerable in their balance sheet strength. And then when they get like a big fire or a storm, there could be very significant damage to the power line. So US, unlike many other developed countries, still has a lot of over the land power lines, and they get very badly affected, especially during such hazards. So PG&E was also the first climate change bankruptcy, even if it was of a gas and electricity utility company. And recognizing that Oregon that workers are going to be exposed to heat and wildfire smoke, etc. The state of Oregon is now planning to actually design rules, and in fact, Biden administration also has some plans along these lines for workers' safety against hazards caused by heat stress. So, bottom line is that I don't want to necessarily say that one hazard is more important than other. Climate often happens in patterns, and then different climate hazards are actually related. If you think about the island of Maui in Hawaii that got damaged, last summer, it had about $13 billion total damage cost. That was actually a combination of hurricanes, heat waves, and then them together causing a very violent wildfire. So it was actually a very interesting compound climate hazard that actually happened at that point.
Bilal, quick question for you.
Yeah.
So this chart that you're showing us,
Yeah.
how easy it is to get these numbers? I mean, how reliable are these numbers? How easy it is to come up with them? And if you want to forecast for
Yeah.
future, yeah.
Yeah.
I mean,
So hurricanes and sea levels, what happens is that the US is a federal agency that actually provides insurance. And based on the claims against that insurance, they estimate damages basically. So the second and the third, which are the gray bars for hurricanes and sea level rise, those are basically like official estimates of damages based on what are called as, I think it's called Federal Emergency Management Association, FEMA. So it's basically their official estimates of damages. The heat wave estimate, I'm going to actually talk about how that is calculated. That is based on a paper in Science called 2017 by author Sang et al. They've built a model called CGLASS, which I'm going to explain in some detail. And I think if there are students who want to figure out how to replicate that model for India, I think it would be like totally fantastic. And I would be very happy to remain engaged offline to discuss how to make that happen, if at all we can make it happen. So we can talk a little bit more about that. Now, how accurate are these? These are projections. So what I'm trying to say is hurricanes and sea level rise is based on realized damages, whereas the estimates of heat wave damages are based on calculated estimated data. Yeah.
can you forecast well in these things going forward? Can you come up with a time series?
So, of course, it's hard, but what climate scientists tend to do, therefore, is they do like meta-averaging across models. So this Sang et al. Paper actually uses 44 different climate science modeling networks. And it kind of does model averaging across a wide number of that. So what happens in these models, which is also an attractive property, is that you basically get for a global warming scenario for the planet as a whole, you get what will be the distribution of temperatures at a given location. So, and now because you have a distribution, you can actually start doing some interesting, even confidence bands and things like that. But I think I'll be talking a little bit more about this methodology, I think, down the line. Yeah. Okay. So what we do in this paper is ask a more limited question. In this paper, we check in municipal bonds, corporate bonds, and equities whether companies that are more exposed to heat stress risk are actually having to pay a higher cost of capital because investors are pricing in that they might have greater cash flow risk, greater default risk, etc. And what we find is that when we estimate these damages, which are over here for heat waves, you can actually get a disaggregated measure of that. And then if you are in a region where there's an extra 1% of GDP of the local region exposed to heat damages, the municipal bonds you pay an extra 15 basis points per annum. If you are a corporate that is exposed, one sigma or one standard deviation more in the distribution of heat exposure, you pay 40 basis points, so 0.4% per annum. And we have a very similar measure for equity cost of capital as well. So these are not sort of like gargantuan estimates, but it suggests that the market is already sensitive to the fact that there is some exposure to heat risk in municipal and corporate bonds and equities which are being issued in the United States. Now, as I said, I'm working on some other paper where we look at adaptation and mitigation by companies. And we are looking at exactly to take the example whether Amazon, for example, given that Arizona and Texas and Florida are having huge heat waves, is it relocating the employment that it has by actually setting up and utilizing more warehouses which are in cooler regions like, say, Michigan or Illinois or Minnesota and so on, so that's the kind of spatial reallocation of activity that might happen if companies start adapting. Of course, in old times, we used to have large-scale migration. And if you think about even older times, villages in India used to have marriages across villages to diversify actually the rainfall risk. Because that way, either the groom or the bride was in a safe family and then you exchange. So, of course, those are very primitive forms of adaptation and mitigation, like large-scale migration or village India economy diversification via the marriage structure. But in modern days, of course, large companies can optimize either through purchase of insurance. So that is one other area where a lot of research is happening, which is what kind of strain gets put on insurance companies because of damages. If insurance is being federally provided, as I mentioned, what are the fiscal implications of these damages, et cetera, et cetera. And actually, in a lot of climate science, people are now saying, so, in banking and financial stability, we think about credit crunch as the mechanism through which the financial sector affects the real economy. In climate change, the slowly evolving notion is that it's the insurance sector, not the banking sector, but the breakdown of the insurance sector that might actually start causing real economy spillovers. Because if there's a crunch of insurance provision on homes and businesses, so most real estate in US, to mortgage it, you require home insurance. And if the cost of home insurance rises, then the housing becomes costly. Now, what has happened in California is that states try to regulate the insurance premia and not allow them to become too high. And in California, because of heat and wildfires, the insurance companies are making a lot of damages, but the state initially didn't allow them to pass on the cost through the insurance market. So insurance companies actually pulled out, but that meant it became hard actually to get a mortgage in California in the first place. And then they allowed a re-entry of insurance companies by relaxing actually the pricing and so on. So many of these things that I'm talking about are actually happening on the ground as we speak in the US. But I think these are the kinds of issues that I think will be quite interesting to think about in the context of India as well. Okay, so just one quick thing is that when we look at this impact on municipal bonds, so that's on the y-axis, and on x-axis, I have the impact of this sort of 1% of GDP exposure to heat stress on that municipality. You find that there has been some learning and evolution in the pricing of risk. Markets seem to be pricing this risk more consistently since 2013 onwards. Either that's because there's greater awareness of heat risk and climate risk now, or it could be that heat risk has actually risen. So earlier, heat risk was small and therefore it was hard to estimate a premium on that risk. But now the risk has got magnified and therefore the premium is easier to estimate in data. And in case of corporate bonds, we find a stronger impact on non-investment grade, so junk-rated bonds, which are in the blue bars, and then the yellow bars show the equity impact. So by and large, you see that the impact is stronger around 2012-13, which is when a lot of the awareness of climate issues in markets became first order. Climate scientists have, of course, been talking a lot about it over the past 20, 30 years at a minimum. And by the way, if you want to read about climate change just as a whole, I highly recommend one book by an MIT climate scientist. His name is Kerry Emanuel. He has written a very pithy book. It's called What Do We Know About Climate Change? I think it's like 75 to 80 page book. You can actually read it today evening if you want. But it's a very terse, but a very coherent and I think at some level very deep and simple book. The more every time I read it again, I realize, oh, I'm completely missed on this important sentence the last time. But I very, very highly recommend it. So he's an MIT professor in climate change. Okay, so let me talk about this measure because I think that might be the most interesting thing we could try and do for India in work on our own. So basically, a paper in Science 2017, they developed this system called CGLASS. It's basically a climate projection model. It's called Spatial Empirical Adaptive Global to Local Assessment System. So it's called CGLASS. To the best of my knowledge, it has not been updated. So maybe someone else has developed a better system, perhaps. I don't know, but it would be good to know that as well. Uh, but what it does is the following. It's based on data up to 2013 using a variety of different climate change models. And it uses basically for a given global warming scenario, it tells you what will be the distribution of climate hazards at a given county in the United States. Okay, so that is the global to local mapping that it does. And it's adaptive in the sense that it recognizes that based on the temperature distributions, Arizona may already have certain protections in its construction industry or manufacturing, and workers may be working, say, from 4 a.m. to 10 a.m. to build a house instead of working in the afternoon because of the temperatures. So when it goes then from the temperature to the economic damages, it actually relies on historical data as to whether what temperature damage does 110 or 115 degree Fahrenheit cause in Arizona relative to a similar temperature in New York. New York will have much more damages because it's not used to that temperature compared to Arizona, and it actually takes account of these sorts of things. Now, of course, if Arizona has already adapted, its energy expenditures may be higher. So one way or the other, you pay some cost for adaptation and mitigation of these things. So, but let me talk a little bit about what climate scientists do in order to model stress scenarios. Okay, so what they do is they basically project scenarios for the planet as a whole. Okay? So these are various such scenarios. So the fundamental input into this scenario is a path of greenhouse gas concentration for the planet, okay, which is what's going to be the emissions from fossil fuels and cement. So that's GTCO2 per year. And each scenario you can see goes out along these dots and the lines. And some of these scenarios are called, basically, some of these scenarios, they are called representative concentration pathways. It's a fancy term, but it basically says what is the concentration of carbon that will deliver a particular range of global warming. Okay, so if you go along the RCP 8.5, which is the scenario that we have chosen to use in our calculation, and I'll try and explain why we chose that. That is a scenario that climate scientists have picked if between 2085 and 2100, the range of temperature on the planet will be higher than in 2013 or 15 by 3.2 to 5.4 degrees Celsius. Most climate scientists think 1.5 degrees Celsius is a given. And, the question is whether we can actually keep it there or not. What do the many lines for each range indicate? Yeah, so the question is, what do many lines for each range indicate? That's basically the statistical uncertainty of mapping basically a particular concentration of carbon for the planet into an average temperature for it. Because, as I said, this averaging happens across 44 different models, and not all models agree on a specific temperature for the planet that will arise as a result of this concentration pathway. Now, couple of quick things. There is a big debate in climate science that, sorry, my internet is unstable, it's saying. Are you still able to hear me, Sandeep?
Yeah, no, it's better now. In between, it fluctuates a little bit, but it's fine right now.
Okay. Yeah. So let me just check one thing, that I'm on the right server. Yeah, I'm on the right server. Are you seeing the slides again as well? Yeah. Okay. So
Yes.
so uh, so there's a debate in climate scientists as to which pathway is more plausible at a given point of time. Okay. And they go back and forth in science journals about, which pathway right now is more likely, etc. For us, it is not as important because we are just trying to do a stress test and get a sense of which region is more affected versus less in a particular stress scenario. Now, as long as the ranking of counties doesn't change across scenarios, which is that, so if I pick a more extreme scenario, there'll be more extreme temperatures. But if Arizona is going to be more extreme than New York, regardless of the scenario, I will still get my ordinal ranking correct across these counties. And because we are going to be estimating the pricing of the heat risk in the cross section of counties or cross section of companies, we need to get the ranking right. It's not so crucial as to what is the specific scenario that we believe is likely to materialize at a future point of time. If you wanted to make a greater sense of the exact risk premium, then of course it could potentially become more important. So let me show you now what is the next step. So there are two important steps from each pathway. Uh, so one important step is that from that pathway, which is an average global temperature, then they use several different models that have gone into this. But based on those models, you actually get a temperature distribution for each county in the United States. Okay. So if you take, here I've shown two cities, Orlando and Miami in Florida. And you can see that the blue line is the baseline temperature distribution. So that's actually the realized Fahrenheit temperature distribution in 2012 in each of these two cities. So that's a realized distribution. And then RCP 8.5 is based on that 3.2 to 5.4 degrees Celsius warming between 2080 to 2099. In that scenario, it says that the temperature distribution will shift to the orange distribution to the right, as you can see. And I've just drawn a vertical line just as a benchmark for what many people think can be considered as a hot day. Okay. So above 100 Fahrenheit, so, maybe that's like about, 35, 36 degrees Celsius, something like that, is what they are considering as a hot day here. We can again have a debate as to whether it should be 100 or 110, but that's not the point. You need to again come up with some classification to calculate hot days. So now what I'm going to do is I'm going to calculate how many hot days were there in 2012. That's a baseline scenario. And how many hot days are projected to be there under the RCP 8.5 scenario. And the gap between the two is going to be a measure of climate change for that county, okay, as a delta projected hot days. How many extra hot days per year will you have as a result of this scenario materializing relative to the baseline scenario? Now, this is available at each county level from this C-glass model. And actually, there is code on their website, and you can actually just calculate this for like every single region. You can vary the scenario on their website code as well. And because we have done it for all the US counties, we know that Orlando is in the 76th percentile of climate change delta projected hot days, and Miami is in the 24th percentile. And I can show you more example. This is Phoenix, Arizona versus San Diego, California. You can see Phoenix is already very hot, but is going to get even hotter. And so Phoenix is in the 81st percentile of climate change, delta projected hot days, whereas San Diego, California is only in the 5th percentile. And if you compare Sacramento to San Francisco, Sacramento is the capital of California state. Sacramento is 63rd, whereas San Francisco is actually in the 1st percentile of. So San Francisco may have other problems right now, but climate change is at least not directly in a heat sense. It's suffering from wildfire coming in through winds, bringing the smog into the city. But at least its own temperature is not expected to rise that dramatically as a result. So, frankly, like I find this a very simple but kind of very foundational measure of climate change. I like it a lot. It's a very simple measure, and it can be varied based on the projection you have of the global warming scenario. It's granular. It's at the level of each county, and I think, in my view, someone interested in climate change for India should really try and figure out whether sea glass or some other papers that have been written like that in nature and climate science journals can be adapted to India to produce this kind of a utility. Because what Seaglass has done is they have made it easy for any researcher to actually calculate a climate change measure at a county level. Now, what's even more interesting is that Seaglass doesn't stop here. So this is a climate change measure. Then Seaglass tries to map this climate change heat stress measure into an economic damage estimate at the level of each county. So how do they do that? So they use two sets of data. Now, here we may struggle a little bit as to whether good data are available for India or not. But in US, basically, you have data on energy demand at the level of each county from a national authority, national agency. And there are labor economic studies which show, based on the temperature in a particular region, what's the impact on different sectors' productivity in the United States. Okay, so what they do is, using these two, they try to map the distribution. So if you see the temperature distribution change in Orlando from baseline to RCP, they try to estimate what will be the increased energy demand in that county and what will be the loss of labor productivity in that county. And then, long story short, they basically convert that into a dollar damage for each county, and then they divided by the state level GDP, suitably weighted for the population of that county relative to that of the state, and create a per capita damage, basically, that you can get out of that. Or it can be per capita, it can be absolute. Of course, you can change that damage measure. The one that we are going to use is just what percentage of GDP of a state will be lost because there will be just dissipative energy expenditures and loss of labor productivity in high risk and low risk industries. So, for example, in case of Orlando, energy expenditures increase relative to their baseline levels in 2012 by 14%. Labor productivity decreases by 2.5% in high risk industries and by 0.5% in low risk industries. Now, the question is, does it matter or not? You can also simply just use delta projected hot days as your measure of climate change. This is a more economically easy to understand measure of climate change, because it's in terms of costs per GDP as a percentage of GDP, so you can attach an economic meaning to it. But I find both quite interesting and informative in their own right. So from my standpoint, I think if I can get someone to actually do something like this for India, it would be quite fantastic. I don't know what it entails. I haven't yet invested the time and effort to learn more, but it would simply be terrific. There are some higher generation models, I believe, beyond Seaglass, and India doesn't record climate at a very as granular a frequency as United States does. but it could be that there are some estimates already available in climate science, even for India, but at somewhat not as granular as they are available for the United States.
Yeah, I'd imagine that, predicting India's climate in 2080 with the current models will probably not be as accurate. I mean, they won't be any accurate anywhere, but all these models don't really calibrate well to India. So there'll be a bigger problem
Yeah,
there.
yeah, exactly. So I think because the models have to be historically calibrated,
Yeah.
and then the simulations have to make sense based on some historical trends. So on the other hand, the good news is that how a particular global warming feeds into El Nino and La Nina and all that is, of course, as all that is easy to understand at the planet level, and climate scientists are building models of even what's happening on the Indian Ocean front and so on. So that is, of course, done. The question then is whether there is good data available at what granular frequency on actual realized temperatures and so on to do the global. So the global to the local mapping that has to be done, that may require finer Indian data, and I don't know at what quality they exist at a granular level, I think. Yeah. But in the US, what's interesting is that there are also off-the-shelf black box measures that industry has started to sell. So 427 was one such company. They basically started providing scores from 0 to 100 for different kind of climate perils: heat stress, drought, excess rainfall, hurricanes, and sea level rise. They first do it at the location level, then they map it into physical locations of each company using another data set. And then they also give you, therefore, a corporate score between 0 to 100. You can see that if you have the sea glass measure and if you have the locations of each company, you can actually do some kind of measure of your own by combining the different temperature distributions and some notion of exposure of a company. So how many employees does it have in Orlando versus Miami, for example? Depending on those weights, you will have different heat score for each company. We have done that, but in this presentation, I don't have the talk updated for that. So for companies, we are going to use this off-the-shelf measure from this company 427, which is now actually acquired by Moody's Analytics, because very soon these things are likely to start figuring into credit ratings of companies and sovereigns and so on. Yeah. Maybe in interest of time, I can just take a pause here if anyone has any questions. Because then I'm going to go into how we estimate the impact of these heat risk onto cost of capital. So that's like this was a climate change module, and then now I'm going to overlay like a finance module on top of that to estimate whether heat risk is priced or not. Okay, so if there are no questions, I'll just move ahead. Just to give you some high-level stats. So the estimate based on the CGLAS model is that an average municipality will have heat-related damages due to energy expenditures and worker loss productivity of about 0.83% of GDP. So that's kind of non-trivial, I would say. Um, and then you also have the decomposition, and you can actually see that about 0.6% of that just comes from higher energy expenditures required for air conditioning and cooling. In terms of the uh, delta projected hot days themselves, because the RCP scenario is very extreme, on average, there'll be 37 more hot days in a year for a county, for a median county, compared to the baseline scenario of 2012. Okay. The question is, how do we break the risk premiums into climate risks and other things like inflation? So as of now, I'm just going to show you in what follows that climate risk has a risk premium on it. Now, whether that's caused because that is somehow causing the macroeconomic risks of inflation to rise, whether that's causing GDP to come down, we don't have a macro model to do that kind of decomposition. That requires far bigger modeling of the economy. And it's probably like it's not my cup of coffee. I think macroeconomists are probably building such models as we speak. Yeah. Yeah. But I think the issue of inflation is very important. In fact, I was talking to Sandeep before the talk started that I'm doing all this work because I'm interested in learning about impact of heat risk for India. And right now I'm trying to understand if food inflation is likely to have a permanent structural shift upwards as a result of the likely impact of global warming and rising temperatures for India. Can there is there another question? Can there be other input parameters for labor productivity apart temperature? Yeah, so actually I didn't talk much about this, but this sea glass actually provides the okay, let me see. The sea glass measure, it provides a mapping not just into like heat, it also provides a mapping into the distribution of other perils. So you can also get exposure to sea level rise, uh, excess rainfall, drought, hurricanes, because all those are part of climate science's simulation models. And Seaglass adopts all of them to actually give you for each county what's going to be the distribution of the hazard risk, and then maps it into economic damages as well. Okay, there's another question. Are the heat risks modeled through ensemble forecasting methods like a broad range of and upper lower bounds on the heat risk? I think that's right. There's 44 such systems that Seaglass uses in particular. That paper was written in 2013. It got published in 2017. I'm sure over the last 10 years, many such more systems have been built. PhDs are probably coming out every day as we speak on this issue. One of my co-author and colleagues' sons who just finished his PhD at MIT, he's built a new simulation model which improves the prediction of El Nino and La Nina forecasts for the Indian Ocean development. So yeah, it is a model averaging across a range of outcomes. Yeah. Okay. Um, okay. So basically, let me just explain what we do. So the structure of our tests is going to be very similar, which is that let's say we first talk about municipal bonds, and I'll go through this sort of relatively quickly because then it's just then a battery of tests one after the other once I set up the structure, and then maybe we can have at least 10-15 minutes to chat at the end more broadly. So let's say you have a bond on a municipal. So I understand this may not directly apply to the India right now because we don't have municipal bonds. We do have state bonds, but state bonds don't have relative pricing because of the support that RBI and the central government implicitly are providing to state bonds. But nevertheless, let me just describe what we have done for the US. Okay, so let's say you have a bond B for a county C at time T. So that's a municipal bond of that county or a utility in that county, etc. And you are trying to estimate whether its borrowing cost, which is the spread over a risk-free benchmark for that maturity of the bond, is related to its heat risk or some other climate risk C. That's at a county level, and it's a time invariant measure. Okay, so it's just an estimate like the delta projected hot days or the percentage of GDP measure, whichever one I showed you. You can even use within the percentage of GDP, the percentage of GDP just due to energy expenditures. So you can even see whether all of the components of the climate exposure to GDP are priced or not. Okay. But what we do is we allow for that cross-sectional pricing of these risks, which is whether there's an alpha that multiplies the risk in affecting the spread on a bond. And we allow that estimate to keep changing over time. Okay, so in each year, this is basically a cross-sectional regression that has a county fixed effect. So that's a level spread effect over time. It has a time fixed effect. So it recognizes that there's some economic cycle that's moving these estimates up and down. And we also recognize that there are other factors that affect spread, both the credit risk and the liquidity component of the risk of the bond. And one important thing we control for is that we directly control for credit rating of the bond having a different impact on the bond market spread as a soak for all the credit risk of the bond. And that's partly because the rating agencies are saying as of now that even though Moody's has acquired this 427 company, as of now, they are not pricing in physical climate risk into the credit risk ratings that they attach. Okay. So credit rating captures other aspects of credit risk as of now, but does not capture the climate change aspect. And so our identification is that if markets are pricing climate risk, however, but it's not reflected in the credit rating, you will actually pick up if you have a good indicator of climate risk across different counties. So what's the joint hypothesis? Several. One is that we have a good measure of climate risk, because if we don't have a good measure of climate risk, you will not pick up any pricing and then it's zero. Second, that whatever is the impact of climate risk on the spread, uh, which is not priced by the rating agencies, is basically orthogonal to the credit ratings. Okay, so you don't just need that somehow there is some omitted risk to which climate change is related. It has to be that it is in a correlated manner to bias us in terms of estimating these coefficients. Okay, but long story short, that's the structure of the test. And we cluster the standard errors, recognizing that there is some panel structure to the data. Okay, so when you do this estimate, I'll just show you the most important ones. What we find is that you can see that the heat damage is priced. The left columns are based on sea glass measure. The right columns are based on this off-the-shelf black box measure from 427. And basically what you see is that 1% of GDP, which is the climate risk measure that we use, has about a 15 to 20 basis point impact on municipal bond spreads, especially starting around 2012 to 13. In case of heat score, we don't have any economic damage to the score. It's just a score from 0 to 100. So if you're one standard deviation more exposed in terms of the score, you have an additional 7 to 8 basis points impact. There's another way to do this, which is not based on controlling for credit rating, which is to say that I'm going to actually match each county to a synthetic county which has similar characteristics to it. Okay. So we match on the coupon, the time to maturity, the county population, income per capita, unemployment rate, rating, etc., etc. And then once you do that matching, you are still, however, left with a difference in the heat damage between the treatment and control. So you can see the heat score, even after matching on all of this, is not matched. So everything else is matched, but the heat score is not matched. And then you can simply look at the difference in the borrowing costs relative between the treatment and control. So basically, you have done like a synthetic control using all the counties which are out there. So we find similar estimates when we do that. And then you have very sort of plausible results that it's the lower rated bonds, long-term bonds, because physical climate risks are somewhat longer duration. It's bonds which are of utilities, which are only backed by their revenues rather than actually being backed by the general ledger of the municipality or the state. So they have less diversification. Those are the ones that are more impacted by this. Okay. Then you can go to corporate bonds, and then here, as of now, I can only show you for this off-the-shelf risk measure, and you get a very similar effect. By and large, for investment grade bonds, the pricing is either zero or even a bit irregular and negative in 2008 and 9. We don't have this problem when we do the matching method, so we don't know exactly why this is happening. But for junk rated bonds, you find that there's a more uniform 35 to 40 basis points impact in the latter part of the sample. There's some additional complication of corporate bond. Some of them can be called back by company. So ideally, when you estimate the credit spread, you have to back out that optionality. Sorry, my internet is again a bit unstable. I think it's my Geo dongle is not as good as it used to be for some reason. Okay. But again, we find somewhat similar estimates. And then let me jump to the last point. We then do something for equities as well. I won't get into this measure, but there is a way of estimating a time series measure using options data, which actually one can do for India, because actually India has single stock options which are traded on many companies. So there is a paper in Journal of Finance by Martin and Wagner, which gives, like, using implied volatilities on stock options, it tries to estimate a conditional required rate of return on equity. And what you find is that once again, you have about 40 basis points impact, especially starting in 2012-13 when we do this. Okay, so relatively uniform estimates across. Now, someone asked about other measures. So we have tried this test for other measures, and by and large, we find that when you so there are two ways that people try to see whether other measures, other climate measures are priced or not. So for example, if you take hurricanes or sea level rise, as I mentioned, there is a part, let me go back to a figure to make that point actually. Yeah. So if you look at sea level rise, of course, there is no exposure inside US, and on the coastal areas, there is an exposure. Okay. So let's say you go to the state of Florida at the bottom right of the US map. You can go a small distance, 100 miles inside from the sea level, and you have a county which is exposed to sea level rise on the coast, but a very similar county inside which is not exposed to the sea level rise. Okay. And now you can see whether these two counties have a differing borrowing cost or not. But what's going to happen is that when you look at the full distribution of borrowing costs across the United States, on the left, you can see there is a much bigger heat gradient. Heat moves far more gradually in terms of exposure, whereas in the middle of United States, sea level exposure is not relevant to the pricing of bonds because there is no variation in their sea level exposure. In contrast, there is a much larger number of counties which differ in their relative heat exposure. It's a more continuous gradient of variation across geography than hurricane or sea level exposures is. So then when you ask the question, how much of the standard deviation of borrowing costs across all geographies in the United States can you explain with heat gradient versus hurricane or sea level? Actually, heat gradient is a much bigger explanatory power. And that's what we find in the data. So when we go and try to use the same method for water score, rainfall score, so water score is basically a drought score, what we find is that there isn't much of an impact on municipal or corporate borrowing costs for anything other than the heat exposure. So what that means is that there may be specific pairs of counties where that risk is relevant for the pricing, but in the broad cross section of the United States, it's the heat exposure as a climate change risk, which is what drives a bigger economically relevant variation. Okay, so let me conclude there. Basically, heat exposure seems to be systematically priced source of risk across municipal bonds, corporate bonds, and equities. It suggests, as someone flagged, that maybe scenarios in which global warming will increase planet temperature by, say, 3.5 to 5.4 degrees Celsius, it's going to be a very bad state of the economy. And therefore, if you are an economy like California that's likely to do particularly bad in that scenario, investors are saying you better pay me extra because holding your bonds is a very bad hedge for that macroeconomic state, which is not going to be very good in that scenario. Okay. One last point. there isn't actually much of an insurance market directly for heat. Okay, so for hurricanes and sea level, there is actually a federal insurance market, as I was saying. There is there's an overall, so on our home in New York, I have a home insurance, but there is no specific insurance market that is out there for heat on a long-term basis. There are some temperature-related derivatives that can be traded on specific regions, but they are very short maturity options that you can trade. So actually, it's an interesting question why this insurance market doesn't exist. Maybe because heat waves, heat related damages are not sort of federally recorded and objectively provided, so that to settle a contract, there is verifiable objective information. But it's quite possible that gradually we'll move in that direction. There's a very interesting report written by one agency in California on what it would take to develop an insurance market for heat risk. But I think these kinds of issues may gradually start become of first order importance in India as well. Let me stop there. Uh, I have at least 10 to 15 minutes, Sandeep, if we want to have a Q&A session. I can stop share and maybe we can even just, I can change my view to gallery so I see everyone.
Okay.
Very good.
I'm just going to clap on behalf of everybody. Thank you so much for your
Okay, thank you. Thank you for hearing me out. Yeah,
presentation.
thanks.
Okay, any questions, anybody on the talk? Just kind of open your mic and speak right up. Now, how, I guess, so Rushil, go ahead, yeah. Viral, you're muted now.
Yeah. Yeah, the question is, do heat waves and climate in general have an impact on health expenditures? I think to the best of my knowledge, I have not seen a very definitive paper on this, but I have seen papers which are talking about health effects, especially related to air pollution. I think, that has a long-lasting impact on respiratory diseases, basically. But I think it'll be interesting to do. Right now, the estimates seem to be more at a macroeconomic level rather than at the level of human beings. But as I was saying, so there's another database that you can use in the US from University of Arizona. It's called SHELDUS. It's a special hazard recording of disasters for United States, SHELDUS. And they report 4 kinds of damages for each county in each month for each kind of a natural hazard. And their natural hazard classification is almost about, I think it's like 12 or 15 kind of hazards, because they have other things like wind, strong winds, gale, stormy winter days, avalanche, and they have some other kinds of climate disasters also. But they have 4 kinds of damages: crop damage, so that's agricultural; property damage; worker or individual level fatality; and worker or individual level injuries. And what you find is that the last two, which is fatalities and injuries, are the highest for heat as heat waves as a climate shock, whereas property and crop damages are much larger for hurricanes and floods. And or earthquakes, but earthquakes are very relatively infrequent. So, yeah, but it'd be nice to have some actual expenditure, health expenditure costs. But what happens is, because the health insurance packages are kind of omnibus insurance packages, you would need very granular claims information in order to do that kind of analysis. But it'd be super interesting, actually. I think there is one more question. Let me just check. Can you explain a bit again why adding 15 basis points to account for heat waves risk? So basically, so let's take the matching approach. So let's say you have a county in Arizona, uh, which has some population, a GDP level, employment level. It has a certain structure of its bond borrowings, etc. But it's very exposed to heat risk, like Phoenix, Arizona, for example. There are several other counties in the United States, and I have macro data for all of these counties, and I have their bond market borrowing structure. So I can do like a simple propensity-based matching algorithm to identify another county, either on its own or a synthetic one that's similar to Phoenix, Arizona. Okay. Then I know the heat score for Phoenix, Arizona, and I know the heat score through the weighted average of synthetic counties that I've calculated as a match. And I can just compare the borrowing costs of these two counties. Another approach that is very common in literature is to look at border counties. So, sometimes two border counties look very similar, but they may be just separated by like a mountain range, and then they may have very different climate patterns as a result of that. And as I explained, another way of doing that is to simply soak out the credit rating in a cross-sectional regression instead of trying to do it through a matching algorithm. Because credit rating agencies claim as of now, and that's a joint hypothesis, that they are not pricing in climate risk into credit ratings, but they are factoring in other kinds of credit risk exposure, which may be linked to either the company or the county's stability as well. There's another question. Do you see which industries are specifically more susceptible to heat risk? Yeah, so basically, when you look at these labor productivity estimates, so farming, construction, mining, and manufacturing are more exposed compared to retail trade, wholesale trade, financial services, and other kinds of services. So the first four are generally high risk exposure industries, and services, trade are, health service provision, etc. That's not a very high risk exposure industry. Then the next question is, in the heat score map for the US, the value around the central western regions were really low, but the central areas as high scores. So is there any particular reason that was found for the low values? Okay, let me just go back to the map. I'm just looking at it. Yeah, I think so. This is like states like Colorado, uh, maybe Nevada. Maybe Nevada will be pretty hot, but like Nebraska, etc., which are sort of along the Rockies, and many of them are at an elevation, and therefore they don't have as much of a climate change issue. If anything, these may be the beneficiaries of climate change because their cold days, which are very extreme right now, may no longer remain as cold. So, Canada is expected to be a huge beneficiary of climate change. Chicago, Michigan, Minneapolis are expected to be big beneficiaries of climate change. Parts of Sweden and Scandinavia are projected to be big beneficiaries of climate change because instead of 6-month long winters, maybe their winters will become only 3-month long or something. Okay, there's one more question. In India, where the bond markets are not as formal, where and how can we observe such climate risk effects? So my sense is, for India, the best bet in my view is to look at equity prices actually. So if one does have a geographic mapping of the type I was describing using Seaglass, then one would have to use something using perhaps company headquarters, or if there is more granular information through Ministry of Corporate Affairs on establishment level locations of each company, then one can aggregate up county level climate risk data by some sales or employment weighted corporate information. And then one can use the options data to construct a required rate of return on equity using this Wagner or Martin and Wagner method. And then I think equities might actually be the best bet in my view. One alternative way is to think about maybe food prices, food inflation, as someone was asking during the talk. And in that, India, because the market is still not that national, there are like regional level, mandi level variations in prices, especially in perishables, for example, because those are harder to move around within the country. So you could actually try and go from regional climate dispersion to regional food level price impacts, and how then you would be getting at spatial patterns of food inflation within the United States. Okay, another question. As far as I understand, the current risk pricing is based solely on the damages you expect due to temperatures. Are there any other interesting factors that you might add? Idea of defaulting and expenditure approach is enough. Yeah, so we can control for other climate risk measures, as I showed in that last table. They don't seem to be priced in the cross section, at least. What are the other things we control for? So either you can soak up everything through a credit rating, assuming that credit rating is picking up a lot of the default risk relevant information, or you can come up with whatever factors you want and then do a matching on the basis of that. So for municipalities, we use GDP, employment, population, tax base, etc., debt to GDP, and so on to do that kind of matching. So basically, the idea is to do incremental pricing of heat risk, because of course there are other characteristics of a county that may be relevant for credit risk and default risk, as you mentioned in your question.
Yes, well, as we have more
Yeah.
of these, I guess global warming, etc.
So like there are limitations of this
Mm-hmm.
approach, of course. Sorry, I think I stopped sharing.